Hello everyone. In this video, we're going to make the clock initialization function using register level coding. And our final goal is to make the H clock as a system clock, which is 72 megahertz, and peak clock 1 to 36 megahertz, and peak clock 2 to 36 megahertz. Well, if you take a look at this clock tree on the datasheet, well, we're going to use the HSE clock, which is 8 megahertz on my board as a source of PLL circuit over here. And so over here is the PLL source. And so, uh, like I s- like I mentioned before, we're going to make the H clock to 72 megahertz as a system clock, and we're going to make the peak clock 1 using prescaler to 36 megahertz. And we're going to make the peak clock 2 using prescaler as well to 36 megahertz. And now we're going to overview a few steps to take in this entire video. It will be around 8 or 9 steps in this entire code. First things first, we're going to set up the flash memory to resolve the speed difference between CPU and flash memory. And then we're going to enable the HSI clock as a system clock before setting up the HSE clock as a system clock because of the safety reason. And then we're going to enable the HSE clock. And then we're going to disable the PLL circuit just for a while before setting up the PLL circuit. And then we're going to set the prescaler for a HB clock and a PB clock. And after that, we're going to enable the PLL circuit. And lastly, we're going to select the PLL output clock as a system clock, which will be 72. And now let's move on to coding part. First of all, we're going to set up the flash memory. And so if you take a look at this reference manual over here, we're going to clear up the latency bits over here to set up the 0, 1, 0 beats for the two states waiting, because our system clock would be 72 megahertz. And so that's the reason why. And so if we transform these bits into hexadecimal number, it should be 7. So this should be 7. And the latency should be 2 wait state. And I already write it down over here. It should be 0, 1, 0. And so if you fill up the bits over here, 0, 1, 0, if we transform it into a hexadecimal number, it should be 2. So this part should be 2. And well, we're going to make the flash memory faster. So we're going to enable the prefetch function in this register. And so we're going to use the bit 4 over here. So we have to enable this bit. So bit 4 should be 1. And now we're going to use this shift operation. And so we have to shift 4 times to enable the prefetch buffer. Well, now let's move on to step 2. The reason why we have to enable the HSI clock first before HSE clock is because of the safety reason. And so if you take a look at this reference manual over here, read the note over here. When changing the main PLL's entry clock source, the original clock source must be switched off only after the selection of the new clock source, which means that at least one clock source should be turned on anytime. And so that's why we're going to turn on the HSI clock first before turning on the HSE clock. And so if you take a look at this reference manual over here, the HSI clock beat is over here. So we have to enable this beat to turn on the HSI clock. So it should be 1, 0. And if you take a look at this condition over here, we have to check whether the HSI ready beat is 0 or 1, and HSI ready beat is over here. So it should be 1 over here to check whether the beat is 0 or 1. And so the code over here should be 1 and 1. And so, if the HSI ready beat is 1, well, which means that HSI clock is working now. And so, but, this condition, the result of this operation would be true, but because of this conversion operation, the entire result over here should be false. So, after that, when the HSI is turned on, we're qualified. We're allowed to move on to the next command. Well, we have to set the HSI clock as a system clock for a while. And so if we take a look at this reference manual over here, we have to put 00 in this part because uh, these beats stands for system clock switch. So if we put 00, the HSI clock is selected as system clock. And so these beats should be 00. So since we are using uh, the conversion operation and AND operation, it should be 3 and 0. And after that, we have to wait until the HSI clock is selected as a system clock. So if we take a look at this reference manual over here, well, the SWS stands for system clock switch status. So if these beats are 00, then the HSI oscillator is selected as the system clock. So to check uh, these beats is 0 or 1, we are going to shift twice, and then we are going to use the AND operation to check whether these beats are 1 or 0. And so we're going to shift twice, and to check the two beats, we have to put 3 because 1, 1 beats. If we transform this number into a hexadecimal number, it should be 3. So that's why I put 3 in this part. And well, if the result of this operation is 0, which means that SWS beats are 00, which means that HSI clock is selected for system clock. And so after that, we have to move on to the next part to enable HSE clock. So the entire result of this operation should be 0 and false. So this number should be 0. That's it. Well, let's move on to the step 3. We're going to enable the HSE clock. And so if we take a look at this reference manual again, well, we're going to set these beats to 1 because these beats means that HSE clock enabled. So we have to turn on the HSE clock at this point. So since we are using the left shift operation, we have to shift 16 times. So this is the right code. And after that, we have to wait until the HSE ready beat is 1. And HSE ready beat is beat 17. And so we're going to shift 17 times. And then we're going to check the beat with the end operation. So if the HSE ready beat is 1, which means that HSE clock is working now. So we have to move on to the next code. So that's why the result of this entire operation should be false. So we have to move on to the next. Now let's move on to the step 4. We're going to disable the PLL circuit for a while. And so if we take a look at the reference manual again, well, we have to turn off this beat. So we have to put 0 in this beat first. So since we are using the left shift operation again, so we're going to shift 24 times. And we're going to use the AND operation and the beat conversion operation to clear up the beat 24. And after that, we have to wait until the PLL ready beat is 0, which means that PLL is turned off, which means that PLL circuit is ready to be modified. And so PLL ready beat is beat 25, I mean. So we have to shift 25 times. So we're going to use the AND operation to check whether this beat is 0 or 1. And so if these beats are 0, the entire of this operation would be false, so that we are allowed to move on to the next part to modify the PLO circuit. And now let's move on to step 5. Well, our goal is to make the PLO source to HSE clock, and we're going to set the PLO multiplication factor to 9, because we're going to set the system clock to 72 megahertz. So if we multiply 8 with 9, it should be 72. So before we do that, we have to clear up these beats first. So, well, to clear up this part, we have to put 1 in this beats, because we're going to use the conversion operation, beat conversion operation. And so if you take a look at this part first, well, the starting point is beat 18. So we're going to shift 18 times. And if we transform this number into hexadecimal number, it should be F. So we have to write down F. And then when it comes to this part, this is beat 16. And so it is super simple. Shift for 16 times. And that's it. And after that, we're going to put the numbers, the actual number for setting up some features. Well, if you take a look at this part over here, 0, 1, 1, 1 means the 9 multiplication factor. So we have to write down 0, 1, 1, 1 in this part. So it should be 0, 1, 1, 1. And so we have to put 7 and shift 18 times as well. And well, and just for a second, if you take a look at this part for a while, they can be written only when PLL is disabled. So that's why we disable the PLL circuit in step 4. So just so you know. Well, after that, we have to set the PLL source with HSE clock. Well, the PREDIV1 has the same meaning as the HSE clock, because if you take a look at this clock tree over here, well, well, actually, these two different name is actually the same name. It has the same meaning, so please don't confused with that. So to wrap things up, we have to set this part to 1 because 1 stands for clock from PREDIV1 selected as PLL input clock. So we have to shift 16 times. And now let's move on to step 6. Well, our goal is to set up the prescaler for H clock and P clock. And so if we take a look at this reference manual, all we have to consider is these parts. So first things first, H clock. Well, since we are using the system clock, the H clock, with 72 megahertz, which is the maximum frequency in this system. So we're not going to divide the frequency with the prescaler at this point. So we have to set the 0 with the beat 7 at least. But to make sure, I'm going to clear up the 4 beats, all of those beats. So if we transform this number into hexadecimal number, it should be F, and we're going to shift 4 times. So if we write down the code F, and I'm going to left shift F for 4 times. Well, that's it. And next up is the P clock 1 over here. So if we take a look at this part, since the H clock is 72 megahertz, so but we are going to use the P clock 1 with 36 megahertz, so we're going to divide the H clock by 2. So we have to set up the beats to 100. These beats should be 100. But before that, I'm going to clear up those 3 beats first. So it should be 7. If we transform 3 beats to hexadecimal number, it should be 7. And we're going to shift this 8 times because if we transform this number into hexadecimal number, it should be 7. And since the starting beats is 8 over here when it comes to P clock 1, so that's why we shift 7 for 8 times. So 7, 8 times. That's it. And then we have to set these number to divide the H clock by 2. So if we transform this number into hexadecimal number, it should be 4. So we're going to write down 4 and shift 8 times again. And lastly, we're going to take a look at the P clock 2. So we're going to clear up this part first again. So it should be 7 and shift 11 times. So we're going to shift 11 times like this. And after that, we have to set the beats into 100 at this point. Because we're going to make the P clock 2 frequency 36 megahertz as well. So these beats should be 100. So if we transform this number into hexadecimal number again, it will be 4, but we're going to shift 11 times as well. So we're going to shift 11 times like this. And now let's move on to step 7. Well, all we have to do is just enable the PLL circuit, because the PLL circuit has the 72 megahertz frequency. So if we take a look at this part, we're going to enable this part. So we're going to turn on the PLL circuit. So we have to put 1 in the beat 24. So we're going to shift 1 for 24 times. And then we have to check whether the PLL ready beat is 1 or 0. So, since the PLL ready beat is 25, we have to shift 1 for 25 times to check the beat 25. So the PLL circuit should be locked at this point. So we're going to shift 25 times. Well, if the PLL ready beat is 1, then this result of this operation would be true, which means that PLL circuit is working now. And, but the entire of this while loop condition should be false, because the PLL circuit is ready, so we have to move on to the next part. So we have to use the conversion operation over here. Well, let's move on to step 8. Well, before selecting the PLL source as a system clock, we have to clear up the switch beats first. So if we take a look at this reference manual, yeah, those 2 beats should be cleared up first. So I'm going to clear up this part. So if I transform this number into hexadecimal number, it will be 3. So I'm gonna put 3 in this case. And after that, I have to select the PLL source as a system clock, which should be 10. So I'm going to put 10 in this part. So if I transform this number into hexadecimal number, it will be 2. So I'm going to put 2 on the code. And now we have to wait until the PLL source is selected as a system clock. So we have to check those two beats because this is the state beat. So to check those two beats, I have to use the AND operation, and I have to put beats 1, 1. So if I transform those beats into hexadecimal number, it would be 3. So I have to put 3 in this case. And well, since those beats are starting from the beat 2, I have to right shift twice to make the operation convenient. So I have to shift twice like this. And after that, um, well, 1 0 means that PLL source is now used as the system clock. So we have to wait until those beats turn into 1 0. So if I turn this number, sorry, 1 0 into hexadecimal number, it would be 2. So it would be 2. So if this entire result of this operation is false, then the clock setting, all of the clock setting is now completed. First of all, to check whether this function works properly, I wrote a very simple piece of code in the main function. If the counter value increases correctly after this function is executed, we can be confident that the clock configuration did not get stuck in any other infinite loop over here. Now I'll press the build button. Build is completed. And I'm gonna press the debug button and wait. From the next video onwards, I'll keep using this function. And so if I press the resume button, and yeah, as you can see, the counter value is working perfectly. And so I hope you find this video very useful, and see you on my next video. Bye guys.